Okay everyone, welcome to this week's lecture, which is on the topic of replication. Just to give you an idea of the key learning outcomes this week, by the end of today's lecture, I hope that you can describe what replication is, but more importantly, because I'm sure most of you know by now what a replication study is, you should be able to explain why it's important in science. We will be discussing the rather sad history of replication in psychology. The key discussion points in terms of the history of replication in psychology are there's traditionally been a lack of incentive, so people haven't been motivated to conduct replications. And when we have finally got around to conducting those replications, which started happening around 2010, that's when we started to see kind of these large collaborations taking part to try and assess how replicable are psychological findings. We see that it's not very good. But then, hopefully by the end, I attempt to put more of a positive spin on the current state of things, because the last 10 years have been a really exciting change in psychology, where people are trying to start to incentivize people to engage in replication. And also, as you know, from the first 2 weeks of this my lectures in this course, we are engaging practices such as open science practices that aim to improve the replicability of our research. Alright, so I want to start with an example. Let's just take that out of the way. I want to start with an example, just to show you that you already know why replicability is important. Let's imagine Bob's conducted a study to investigate if males who walk 30 minutes per day with a weighted vest lose more weight than people who walk without a weighted vest. Okay, so simple study, weighted vest versus non-weighted vest among males. And so he takes two random subsets of men, two random samples of men. He puts half of them in a heavy weighted vest. He puts the other half in a light vest, and he has them walk. And his results show that 2 months later, people in the heavy vest lost 6 kilograms. People without the heavy vest lost 1 kilogram. So that's a 5 kilogram difference. And you can see afterwards that when he measures people, this is the results he gets, and he thinks, excellent, my weight loss program is fantastic, everyone should start wearing weighted vests. Let's imagine that Bob did this 10 years ago, and since that time there's been lots of replications, so lots of people have come along, seen Bob's study and thought, I want to see if that works, if I can replicate that result, and let's say that of 100 studies, the majority have, and the majority claim to follow Bob's methodology. Let's say 95% of them successfully replicate the finding. So, 5% didn't, but 95% do. And when you take the meta effect, so meta basically means when you look at all the studies and you take the average effect, you find that, yeah, Bob produced a slightly more 5 kilogram weight loss, but the average weight loss of all those 100 studies was 4.2 kilograms. In other words, Bob's finding successfully replicated. How do you, assuming all this is true, how do you feel about that study? Do you think that this study unveiled a truth about the world? That it turns out to be the case that when men generally, when men wear weighted vests and they walk 30 minutes a day, that's a good way of losing weight? I mean, certainly, an average of 4.2 kilos. It's nothing to turn your nose up. It takes 30 minutes a day. 95% of studies replicated the finding, which is pretty good. However, so that's good. That's a way that replication can help you think that a certain finding is reliable. Okay, now imagine the same exact study was conducted with the same exact results, but this time 95% of the replications fail to replicate the finding. And when you look at the overall effect, obviously it's very rare it wouldn't be the case that you get an exact 0, but it's very close to 0 effect. When you take the average effect across all studies, it's 0.002 kilograms difference. So for all of that 30 minutes a day for 2 weeks, the only effect of wearing a weighted vest was a 0.002 difference. In other words, most 95% of the studies now fail to replicate. How does that make you feel about this finding that Bob is suggesting exists? Okay, well, I hope that what I did was it showed you intuitively the important role that replication has in science. This gentleman is Karl Popper. He is a very influential philosopher of science, yeah. And he, when discussing what makes something a science, claimed that real effects may be defined as that which can be regularly reproduced by anyone who carries out the appropriate experiment in the way prescribed. So psychology, if psychology wants to be a science, what we call an effect must be replicable, according to Popper's demarcation criteria. Now, not so much his criteria, but so much what constitutes a science. Now, you can date this back earlier than Popper even. So back in 1926, Dunlap said, "The ability to systematically replicate research findings is a fundamental feature of the research process. Indeed, the idea that observations can be recreated and verified by independent sources is usually seen as a bright line of demarcation that separates science from non-science. In other words, trying to replicate the results should be what constitutes, at least partly constitutes, science." Now, of course, it's the take-home message is if a finding is reliably replicable. So we don't expect it 100% of the time, because there's always going to be some sample variation. Or some reason why we can't expect 100% of our samples to demonstrate an effect if one exists. But if it's reliably replicable, then we say that our theory is supported. If a finding is reliably unreplicable, we consider that theory to be either degenerative, either it's limited, we have to start to realize that it doesn't explain everything that we thought it could, or if it's been even more reliably shown to be unreplicable, then ultimately we say we cannot replicate this result. This theory is falsified. I want to just touch on the topic at this stage of what a direct, sometimes referred to as an exact replication is, and versus a conceptual replication. Okay, so a direct replication, it's when a study's been done, and I want to replicate that as meaningfully as possible, as exactly as possible. So the original study was, and the previous slide was conducted on a sample of men. So if I wanted to replicate that, I'd recruit men. I'd use the same materials and procedure. Maybe I can't get the exact style of vest, but I'll use the same vest or one similar to it, one theoretically similar enough to it that it shouldn't make a difference. And then I test to see if the same materials on the same population get the same result. Okay. An important point about what is a direct experiment is that, or direct replication, sorry, is that it should be the case that all theoretically relevant components of a study are replicated. Okay, so there'll always be differences between studies. If you took two groups, if you recruit two groups of men for this replication, and you measured them on all kinds of variables, you will find differences between that group and the original participants in the original group. Okay, so on some levels, it's almost impossible. It is impossible to do an exact direct replication. That said, the only important thing for a direct replication is that prior to conducting the study, given your knowledge of the theory at the time prior to conducting that study, you have replicated everything that you thought was theoretically relevant to the outcome. Okay, so you can do this by reading the original study, and you can see what they thought was theoretically relevant. Maybe they thought it had to be men, it couldn't be women, and so on. Okay, and of course that you do the same materials. Okay, so and we'll see why this is an important point about what constitutes a direct replication later on. You could also do a conceptual replication. This is when you manipulate in a controlled manner certain components of the study that are theoretically relevant. Okay, so Bob showed this effect on men. Maybe you're interested, does it replicate on women? Bob showed it on, so you recruit a sample of women. Bob showed that it works if you have a vest. Maybe you have reasons for thinking the arms might be more effective. And a hat maybe. So you give your participants wrist weights and a heavy hat to wear. Okay, and then you're looking to see, even though we've manipulated these theoretically relevant components of the study, do we get the same results? So that's now the purpose of doing a direct study is to essentially find out, does the study, is it reliable? Can we reliably reproduce this result? The purpose of doing a conceptual study is to see, can we generalize it? And it's about expanding the original theory. We know this theory applies to this subset of people for these reasons. Maybe it can apply to these as well. And if not, we learn about the theory as well. Okay. So they're the two types of replications that we'll be discussing throughout today. Another thing you should know from the get-go is what actually constitutes a replication. Brandt and et al. So they released a paper in 2015, which they called the replication recipe. And what makes a replication of a study is that the authors have carefully defined the effects and methods. So you have to be very precise about which of the effects and methods from that study you're reproducing. It is possible to do a partial replication, or it is possible to only try to replicate a part of the study, so you have to be very clear. You have to follow the method as carefully as possible, even if you're doing a conceptual replication, where you want to see if it extends to another kind of field or another kind of sample. Then you still need to make sure you follow the rest of the methodology as carefully as possible. You have to make sure you have a sufficient number of participants. We're going to be talking next week all about sample size and how important it is to make sure that you have what's called a sufficiently well-powered study. Power doesn't mean social power, which is one of the examples for your assignment. Power in the statistical sense means that you have it's the ability to detect an effect if one exists. So you need to make sure, if you're looking for a really big effect, then you only need a few participants. But if you're looking for a small effect, if your manipulation only influences your two samples very subtly, very slightly, then you need loads of participants. If you don't have enough participants, you might fail to replicate the study just because you didn't have enough participants to detect such a small effect. But don't worry too much about that, we'll get to that next week. You have to make sure you provide complete details about the replication. Other people must be able to assess whether or not your replication was any good. And you have to be critical when comparing to original results. So, for example, it's not just enough to know if you got a significant result and if they got a significant result, the original study got a significant result. You might not get a significant result for whatever reason, but maybe the effect size, the difference that you caused, was the same. Even though for whatever reason you just didn't get to a significant, your p-value wasn't significant. Okay. And then the idea is that you take all these components of what makes a good replication, you mix them up, and that's when you create a yummy replication of your own. Okay, so given that I've outlined how important replication is to the scientific method, and given that I've outlined the five things that you need to do a replication, and they're not that difficult, let's review now the sad history of replication in psychology, because it's not too good. For the vast majority of the time that psychology has been a subject, replications were not really incentivized. You could be forgiven for thinking that psychologists just didn't care about replication. I've got a few papers here that discuss this. So Martin and Clark in 2017, they reviewed 1,151 psychology journals. I didn't even know there were that many. And only out of all those journals, only 33 stated that they accepted replications. Now, it doesn't mean that other studies didn't accept replications, but it just means it didn't explicitly state, come to us, we will publish your replications. That's 3%. Okay, now, bear in mind, all the philosophers of science agree largely just how important replication is. It's kind of weird that only 3% of psychology journals invited replications. Mackel and colleagues in 2012, they looked at 100 psychology journals, and they looked at they searched all of these. So they did what's called data text mining. They searched for the word, anything with the word replicat, so REPLICAT, and then anything starting with that, replicat. So it could be replication, it could be replicating. They searched how many articles included that, and they found I think it was about 1.6% of articles did. But when I looked at those articles, only about half of them, I think it was about 68% of them, actually had replications in. So their final estimation of how many articles are replications was 1.07%. Okay. Now when you look at this graph, it's a little bit small, But when you look at this graph, it's the dashed line shows, so if we go here, this dashed line shows that the percent of articles that are replication studies. Okay, and you can see it's grown over time, which is good. But don't forget, over here, these bar graph here shows the number of studies published in each year. So of 100,000 articles published, only just over 2% were replication studies. Marsden looked specifically at a subset of a subcategory of psychology, second language research. They found that there was only one replication for every 400 articles, which is just crazy when you think about it. It's just for 400 articles come out, one of them gets replicated. On average, there was 6.64 years between an original study being published, making a claim about the world, and somebody replicating it. And I believe this study also found that the chances of it being it was more likely to be successful. So we've already discussed publication bias, so that could be bias of research anyway. Maybe there had been more replications, but they were unsuccessful. And then on top of that, if there was an overlap of the original author. So if the original author also did the replication, it was more likely to be successful. Now this is just a breakdown of all the number of replications in each of the journals I looked at. But this is the key detail here. It breaks down to 0.66%. So in this field, only 0.66% of articles were replications. Okay, which is, again, remember, replication is a crucial part of science. And if you wanted to have a good reason as to why we should be doing replications, they also included a list of outcomes. So as you can see, I haven't got my glasses on, 15% of replications did not support the original hypothesis. 13% partially did not support it. 35% partially supported it. 34% very supported it, and 3% were unclear. So there's a real range here of support for articles, which is saying we should be doing these studies, because look how many were only partially or partly supported, or not supported at all. And they even made this comment: our sample contained no direct replication attempts, and changes made to initial studies were numerous and wide-ranging, which slightly obscured, if not undermined, the interpretability of replication studies. So one of the nice things about direct replications is you can say, we kept everything as similar as possible, this doesn't work. When you do a conceptual replication, it becomes a little bit hazier. It's a little bit more uncertain as to is the theories not supported, or did the changes you make mean that it's no longer a direct test of our hypothesis or of our theory? It's hard to say. Okay, so that's a history of psychology and bad news about how often it's been incentivized, and you really can be forgiven for thinking that for a long time people just did not care about replication, even though simultaneously we knew how important it was for a thriving science. In 2011, this man, Brian Nosek, who's a big name in research methods and has a massive impact on psychology, he formed the Reproducibility Project, which started with 60 members and over time grew to 270 members from over 50 countries. Okay, so it was a huge project. I was just doing my PhD at this time, and it was just getting going. And what their job was to replicate 100 replications from 3 prominent journals. So these are 3 of the biggest journals in psychology: the Journal of Personality and Social Psychology, Learning, Memory and Cognition, that's Journal of Experimental Psychology, Learning, Memory and Cognition, and Psychological Science. And it's important, of course, as you might expect by now, 97% of the original studies reported significant effects, and I think the ones that didn't were just off significant. They were just marginally significant, but they still supported the hypothesis, even though it was marginal. These graphs demonstrate the results. Okay, so on the left here, you have on this axis, you have the p-value, and as you can see, on the original studies, the majority of p-values, a vast majority of them, were below this dotted line, which is 0.05. And as you can see, as I mentioned, there's a couple of studies that just were on the other side of 0.05. So if we replicate the results, if we did the studies and they all replicated, we should get the same distribution of p-values. But as you can see, we get a vastly different. The vast majority of studies obtained non-significant p-values. Only very few obtained significant p-values. Now, what you'll be learning in statistics at some point is that just because something's significant doesn't mean the effect size, and I'll be talking about effect size in a little bit later on next week. But the effect size is essentially how big of an effect does something have on something else. Okay, so let's just say if you lose if an exercise program causes you to lose a lot of weight, we say it's got a large effect size. If it causes you only to lose a little bit of weight, we say it's a small effect size. Okay, so as you can see here, the average effect size was about 0.4, I guess, which is about standard average in psychology. And when we replicated it, we found that the average effect size was a lot smaller. Okay, it was around 0.1 here, it looks like. Okay, but as you can see, some went up high, but there were fewer studies getting large effect sizes, and many studies getting effect sizes in the opposite direction. So if we were to stick with our weight loss thing, people in the vest actually gained weight versus losing weight. Okay, so there's two things here. There's a p-value, is it significant? And then there's also the effect size. And usually a larger effect size will be significant. But as you can see, we got much smaller effect sizes. So even the studies that did work produced smaller effect sizes. Okay. And the replication rate was 36%, and this was really shocking for psychologists. As a science, we want to be able to predict behavior, and here we're saying when we do things in the open, when we pre-register our methodology and hypotheses, we get 36. Most of our studies don't replicate. Now there is a little asterisk to that, and that asterisk is, which I mentioned last week, that oftentimes replicators, especially at this stage, were choosing to replicate studies that they were skeptical of. And we saw with the Lacan study last week, when they were assessing pre-registration, replication studies had a lower rate of being successful, probably because when I say be successful, I mean they were more likely to support than null, probably because people that replicate studies tend to be skeptical of the original studies. So they choose a study that's less likely to replicate, and then when you do a pre-registered study, you find, of course, that it didn't replicate. I wanted to just talk you through some of the examples of studies that have failed to replicate over the last few years. Let me just see how I'm doing for time. Thank you. Okay. One of the first studies that really started off this discussion about replication in psychology was this study by Barge and colleagues. Barge is a big name in psychology. He's a professor, and he was known for this social priming. Essentially, what social priming is when you present a concept or an idea, and that has an impact on behavior. Okay, so by activating a word associated with the concept of old age, by presenting, for example, words such as worried, Florida. Apparently, Americans associate Florida with old age. The word old, lonely, grey. By presenting these words to participants, you activate the concept of old age. And Barge claimed that by doing so, that people start to behave in ways that are congruent with old behavior. So in his study, he asked participants to complete words. It's a word completion task. And he either asked them to complete words associated with old age, or he asked them to complete words that were more neutral. And what he did was, when he thanked participants and told participants to go and receive their payment, he timed how long it took participants to walk down a corridor. And these are the results. As you can see in experiment 2, people took about a second, this is 2A, about a second longer, and about the same difference was found in experiment 2B. Okay, so it took elderly people about a second longer to walk, not elderly people, say, people that have been presented with elderly words, took about a second longer to walk down a corridor. Now, in 2012, Doyen did a simple replication of the study, and what he found, he actually replicated the result. When he had experimenters time the participants to walk down the corridor, he did find this result here, where you can see if you ignore the fast condition, because that was something else, he's looking at whether they were primed with old age words or they were not primed with old age words. Sorry, this side is primed, this side is no prime. And as you can see, it did take those participants primed with old age words, it took a little bit longer. However, he also had what he called an objective measure. And this is a slight difference still, but this actually revealed no significant difference. Okay, so when participants walked down the corridor, they passed between two infrared lasers. and those lasers timed the behavior. And what he found was, even though the experimenters found an effect, the lasers did not. And he argued that therefore maybe, in these studies of barges, it's not so much that the priming of a construct that affects behavior, but more the experimenter's expectations. By today's standards, this is a very simple study, not that big of a deal, but actually Barge reacted quite poorly, I think, in retrospect, online. He made up a couple of blog posts. He attacked people for that had tried to do the replication and claimed it replicated just fine, thank you very much. It hasn't aged well. Another example, more recently, of a study that didn't replicate is the facial feedback hypothesis. Okay, so this was a study conducted by Strack, Martin, and Strepper back in 1988. This is actually a slide I used to present this to my master's students in the master's course I teach, and I used to teach it. And basically, this is a picture from the original study. If you have participants hold a pen like this between the teeth, the idea is that you activate the zygomaticus muscle. This is the muscle responsible for us smiling. And if you and if you hold it between your lips, you inhibit that muscle. And so what Strack and colleagues did was they had participants hold the pen this way, or they had participants hold the pen between the teeth to activate the muscle, and they then had them read cartoons. And what they found was, if you look at this line of the table here, participants that held it within their lip that inhibited the activation of that muscle reported that the comics were less funny than participants that held it between their teeth and activated that smiling muscle. So the idea is this embodiment idea, that by activating the smiling muscle, we infer from the fact that as it's activated, that we find it more funny. Interesting hypothesis. Unfortunately, a few years later, in 2016, so again quite recently, Wagenmakers is someone who's been a big player in kind of the reproducibility movement and this credibility crisis, improving psychological science. Okay, but he led this registered replication project, which involved many teams. He had 17 independent direct replications, so 17 teams around the world tried to replicate this study for a total of 1,894 participants. I just want to spend a couple minutes explaining how to read these kind of graphs. This is a forest plot. So on the left here, you have each of the teams, and you might notice this one person here, Dermot Linnet. Dermot Linnet is a lecturer in our department, and you guys are going to be having him teach you next term. He's teaching the Psych 124, which is the sister module to this module. So these are the labs that took part in the study. This is the effect size up here. So the original study, you don't need to know what the numbers mean. Just know that the original study found an effect size of 0.82. Okay, that's probably, I think that's the difference between holding the teeth like this and holding the teeth between your lips. So what did each of the studies find? In the replications, you can see that the effect sizes are much smaller. Okay, and the average difference is about 0. So as you can see, every single lab differs slightly from 0, but they dance around 0, which is what we would expect if the null hypothesis were true. And then if you take the meta-analytic effect, that's the average effect size, you see that it's actually a tiny amount, 0.03. Just to let you know, when you read these graphs, if these lines don't overlap with zero, then it's significant. So you can actually see that the original study, I believe that means that it wasn't quite significant anyway. It was marginally, they would have called it marginally significant. Okay, so just not significant. Whereas you can see all of the replication projects pretty much were completely non-significant. And then the overall effect size is 0.03. So this is another example of a study that when you do everything out in the open, remember, this is a registered replication report. As you guys know by now, because you're writing one yourself, this is submitted, they had to submit the introduction and methodology beforehand, had to have everyone agree on it, and then they would have conducted the study, written up the results and discussion, and submitted stage 2. So this is a good example of what you guys are doing. You're doing a slightly more basic version, but of what you will be doing for your assignment. Now, I don't have time to go through every single failed replication in psychology, because there have been a lot of them. What I've done on this slide is I've just listed a few topics that you might want to Google. You can, elderly primary I've covered. Professor Fryman actually took part in that registered replication. Myself and Dermot both took part in that. That's when you prime someone with the concept of being a professor. So you ask someone, what's it like to be a professor? And you ask another group of people, what's it like to be a football hooligan? And then the original study found that participants that thought about being a professor scored higher in a general knowledge quiz than participants that thought about being a hooligan. And of course, it completely didn't replicate. That's another priming study. I won't go through any of them. I'm going to talk about growth mindset towards the end of today anyway. But if you're interested, power posing's received a lot of feedback, a lot of attention. Power posing is the idea that by posing in certain ways, it makes you feel powerful, and it increases your certain, like testosterone and other hormones that make you feel powerful. And again, it just hasn't really replicated very well. There's also been other projects. So I talked about the reproducibility project. In 2014, Daniel Akins and Brian Nosek being the guy that took the lead on the reproducibility project, they had a special issue in a journal called Social Psychology, where they attempted to replicate 15 findings. Dermot Linnett also conducted a study. He conducted one of Barge's studies. He tried to replicate one of Barge's studies actually, and it didn't replicate as well. That was a study that if you hold warm drinks, you're more, and somebody asks you, do you want to donate some money or keep some money or something like that, that people who hold warm drinks are more warm, behave more socially warm than people that hold cold drinks. And again, Dermot found across many more participants that it just didn't replicate. Across that journal, only 30% of studies replicated, so even worse than the reproducibility project. Nature, more recently, I believe this was 2015. Do look this up. I believe it must be. I think it actually came out in 2017. Okay, but it was published in Nature. They tried to replicate studies published in Nature. So Nature's quite a high impact journal. So you would hope that therefore it means that it's quite a high standard of quality. They replicated 21 studies. The replication rate was a little bit better. It was 62%. And they also did a cool thing where they had they asked people to bet, will this replicate? So they basically had people gambling as to whether or not a study would replicate successfully. And an interesting finding from this was that, as you can see from this line here, if you recall back to your when you were learning correlations, you can see that there's actually pretty good predictability. The studies in yellow were non-significant, didn't replicate, and you can see that people didn't bet very much money. So to the left on this x-axis, each of these, by the way, in the y-axis is a study, and you can see that people didn't think these studies would replicate, and they didn't. And then over here, people felt pretty certain these studies would replicate, and they did. Which is just an interesting finding. It turns out that people are pretty good at knowing which studies will replicate and which studies won't. An important thing to consider is what happens when replications fail. Okay, now Karl Popper knew that not everything is like physics, where it either is or it isn't. Okay, and even when you get to theoretical physics, nothing is or isn't. Schrodinger's cat, etc. But psychology, especially, is something where it's more of a probability. You don't expect something to work on everyone. There's no universal laws that will simply apply to everyone in all contexts. And Popper knew this. Popper said a few stray basic statements contradicting a theory will hardly induce us to reject it as falsified. We shall take it as falsified only if we discover a reproducible effect which refutes the theory. Okay, so Popper knew that just because a study doesn't replicate once or twice doesn't mean that the theory is completely falsified. It's an accumulation of evidence that has to be reviewed in order to determine, does this effect seem replicable overall? And there could be many reasons why a study doesn't replicate. It could be because, there was a problem with the original study. They forgot to report certain information that they should have included. There could be what's called a moderating variable. So let's say you do a study. Let's go back to my first lecture where we talked about Professor Starbucks and his study where he found that coffee improved student performance, or allegedly. Maybe let's assume that he did this study really well, perfectly, and it was a good study and he found the effect. And then I come along and I decide to replicate his study before I buy all my students coffee. It doesn't replicate. It might be the case that Professor Starbucks students, because he found his students from coffee shops, because he runs a chain, maybe they all love coffee, so it worked. Maybe my students, they hate coffee, the majority of them hate coffee, so it didn't work. When I review why my study didn't work, that might pop into my head. That might be a reason why. Perhaps I do another study where I monitor how much people like coffee and see if that acts as what's called a moderator. So we have people that do like coffee, people that don't like coffee, and we compare them. If I find that the people that like coffee, the effect does hold up, and the people that don't like coffee, the effect doesn't hold up, then I've successfully replicated Professor Starbucks' coffee, but I've extended the theory by identifying a moderator. That's a limiter. That's knowing when the theory applies and when it doesn't. We'll be talking next week about sample size. I've already briefly mentioned it. Sample size essentially means it's relevant here because if you don't have enough participants, if you're looking for a tiny effect, you need a lot of participants to find it reliably. If there's low variability in outcome, so if everybody is affected in the same way by your independent variable, you'll have a massive standardized effect. If there's loads of variability in outcome, so people are affected slightly, some people are affected a little bit by your independent variable, some people are affected a lot by your independent variable, you'll have a small standardized effect. Okay, so the standardized effects are all about how much variability in the outcome there is, in addition to any mean difference. Okay, and if you have a small standardized effect, you need a lot of people. If you don't have enough people for the effect size you're looking for, then you might not detect it even if it exists. So you might fail to replicate a study even though you would have replicated it had you had sufficient number of people. There's also the notion, by the way, on the topic of sample size, that if you have a small sample, then as you know from your lectures with Sally, there's loads of variability. Okay, the more participants you have, the less noisy your data gets. But when you first have a small sample, there's potential for lots of room. Maybe you get 3 completely different people to the population. You get 3 extreme people, and so there's lots of noise in the data. As you add more people from the population, you'll find that the noise in the data reduces. Okay, so if the original study had a small sample, which is a problem in psychology, you might find that they found an effect, a huge effect, which would, as they recruited more participants, had become a smaller effect and more accurate of the actual population effect size. But because it was based on these very few people, and therefore it vastly overestimated the difference, then you assume that the effect size might be bigger than it actually is. So you are now conducting a study assuming you're looking for a big effect, and so you recruit that many participants, but actually you're only recruiting, you would actually need many more people to find a true effect. And if you recall back to the reproducibility project, the results of that, the original studies that tended to have much smaller sample sizes also found much bigger effect sizes. Okay, so one reason is that original studies might overestimate how many the effect size, how big the effect actually is. The last issue that could happen is that there could just be inherently, the original result could be inherently situational or contextual. So, if you're investigating social media, so let's just say you're investigating trust in media, okay? And there's a study in 1960 that was conducted that demonstrated trust in social media is influenced by X, Y, and Z. And then you do this same study, you think that's interesting, let's replicate that in 2020. So much has changed. There are so many theoretically relevant variables that have changed, including exposure to social media, to media. Who gets to be media? How much the media have been shown to provide false information, and so on. What access you have to knowing that media is now providing false information, and so on. That it's actually pretty okay to just admit what was probably true back then might not replicate today, and it's not necessarily due to an issue with the original study. Okay, that said, there's always benefit to doing replications, and one of the benefits is that if it fails to replicate, at least you can identify limits for whatever reason. Maybe it's a limit of the original study, maybe it's a limit of the replication methodology, maybe it demonstrates that this was true at one time but not today, and so on. The reason I'm flagging this is because this is a slide from week 6, when I asked you to pause the screen and try and come up with some reasons as to why these relationships might happen. So for example, if we take the bottom one here, number of people who drowned by falling into a swimming pool and films Nicolas Cage appeared in. Your brain can immediately, if you pause the thing right now, the lecture right now, you can immediately come up with a reason as to why the number of people drowning in swimming pools might correlate strongly with how many films Nicolas Cage appears in. Maybe Nicolas Cage films are so bad that they just force that people feel compelled to jump into the pool and drown themselves after watching them. Seems good to me, and the data supports it, right? Well, as you know, that's a post hoc. That's harking. Okay, we found an effect and we created a story. You should be careful if any of you ever conduct a study that's replicated, be careful of engaging in a similar process to what I just did as to why the original study might have failed. Okay, remember, Richard Feynman is a physicist, very smart guy, recommends you read his books. He's quoted as saying, the first principle is that you must not fool yourself and you are the easiest person to fool. To give you an example, let's go back to this slide where this is the facial feedback study, Strack and colleagues. Okay, I mentioned that this failed to replicate, and the lead author, Strack, came out with a response. And I'm not picking on Strack for any particular reason. Okay, I could have picked any one of a number of original authors of studies that have failed to replicate. They typically come out with things such as this. Strack released a commentary, which is good, you know, on the failed replication. And he started off by saying, "Let me laud the replicator's effort in this extensive enterprise. I admit being very surprised that the original finding was not obtained." That's a key detail. He was very surprised that the original finding was not obtained. He then goes on to state all kinds of reasons why, of course, it wouldn't have been replicated. He says the original study is commonly discussed in introductory psychology courses. Given this, it's difficult to understand why participants were overwhelmingly recruited from the psychology subject pools. Now, there were questions about did you guess the hypothesis of the study and so on, and participants, of course, said no, and if they didn't, they were excluded. Already, this is providing a limitation. He's saying, you know, apparently, according to the original author, this effect won't work if anyone's been exposed to having been told about it. So I'm sorry to all of you that I've just ruined the effect for you. But by knowing about the study, it won't work on you. Now that's a legitimate. There is some truth to this. Okay, if you're aware of effects happening, then you might be less susceptible to them. But remember, it's not like participants were primed. They weren't explained, this is the effect we're looking for. Now we're going to try and do it to you. Just because they've been taught about it once in a psychology class. If I asked you about this, if I asked you guys about this study in a year's time, very few of you will remember the exact details. Second, and despite the obtained ratings of funniness, it must be asked if Gary Larson's The Far Side cartoons that were iconic for the zeitgeist of the 1980s instantiated similar psychological conditions 30 years later. He's essentially saying maybe the cartoons weren't funny enough anyway to elicit a difference. Again, a reasonable explanation. Possibly. Third, it should be noted that to record the way of holding the pen, the labs deviated from the original study by directing a camera. Based on results from research on objective self-awareness, a camera induces a subjective self-focus that may interfere with internal experiences and suppress. In other words, the replication projects, in order to make sure everyone was doing a study right, had a webcam on top of the computer. Apparently, this is sufficient enough to prevent the facial feedback hypothesis from happening. So it's enough to make people, for some reason, notice he doesn't explain the mechanism of how, he just alludes to it. Somehow that prevented activating the psychomaticus having an effect on how funny people rated the jokes. Now, again, I'm not picking on Strack with this. It seems that every time that a large-scale replication project is conducted, the original author comes out with reasons like this. And it's really easy to do after the fact. I want to point out that Strack admitted up here to being very surprised. Okay, so beforehand, he would have had a chance to look at these materials, look at the procedure, and he would have had a chance to say, yep, I think this is going to replicate. And then when it doesn't replicate, it's very easy. It's always going to be possible to look at differences between any two studies and say, well, clearly it would have replicated if only you hadn't had this difference, and this difference. Okay, so you got to be careful. Now, An extreme version of this, I think, is with the growth mindset literature. So growth mindset, I'm sure you've all heard of it. They teach it a lot in schools and stuff now. It's been pioneered and really led by Carol Dweck. And you can read all about it. She has a website and everything. And essentially what it means is that people who grow up thinking that you can change, that you can grow, that you're not a fixed person, you're not someone who's just bad at maths. Maths are skills that you can acquire if you put the hard work in. That's a growth mindset. A fixed mindset is somebody who says, I am bad at maths. I was born bad at maths, I can't do maths. Okay, so that's the idea. And the idea is that by convincing people, and she does a lot of work with children, but that by convincing children that you can be whatever you want to be if you put the work in, you're not born a certain way, you can improve how much they learn and their performance in various tests. Okay, and she demonstrated this. Her original effect sizes were huge, so she claimed that this was massive. That by changing this subtle difference and teaching teachers how to kind of foster a growth mindset, you can improve the grades at school and so on. And everywhere, and I mean this findings everywhere. Her book has been sold over 1 million copies. I think it's called The Growth Mindset. NASA, I found this document from NASA where they recruit people based on and trying to foster a growth mindset. You can go to this website from the UK government about recruitment, where they talk about why you probably are hiring the wrong people. I don't have my glasses on, but they cite Carol Dweck's research on there and talk about fostering a growth mindset. Schools programs in America and the UK have taken up this idea that we should get students to think more about having a growth mindset. The problem is that the claims are huge. Okay, so number one, the original study produced huge effect sizes, probably implausibly huge considering the minor manipulation that they're making, and they haven't replicated across a number of attempts. So when you do a study that's up front, pre-registered, transparent, you try and find this effect, you get substantially smaller effect sizes. Often in the wrong direction, and usually, I wouldn't say usually, but often non-significant. Okay, Carol's response to, and by the way, I've linked to a BuzzFeed article, which is actually a really good article that covers the whole debate that's going on about growth mindset. And her response to failed replications has been to say, we put so much thought into creating an environment. We spent hours and days on each question on creating a context in which the phenomenon could plausibly emerge. Replication is very important, but they have to be genuine replications and thoughtful replications done by skilled people. Very few studies will replicate done by an amateur in a willy-nilly way. Now, if you read that BuzzFeed article, it interviews somebody called, his name escapes me. I'll remember it in a sec. But he's one of the people that investigated Brian Wansink and found a number of errors that Brian Wansink made that eventually meant that Brian had to retire. If you remember, we talked about Brian Wansink last week in our pre-registration lecture. I can't believe I've forgotten the guy's name, but he points out that Nick, I don't know. I'll look it up. I have to let you know. He points out that if it's the case that only a really skilled researcher is able to replicate this study, because it's really, it's very skilled set, and you have to be very careful with how you do it, then how can Carol Dweck claim that teachers who are not skilled in research, not skilled in the growth mindset, are able to generate these effects? How can they claim that NASA, how can the government claim that people who own businesses who aren't skilled psychologists are able to generate these effects either? It's kind of a catch-22. You do a study and you claim that this study demonstrates that just by changing something very subtle in how people think about themselves can produce a massive effect in performance. And then when a study comes along and says, okay, we tried to find this effect and it doesn't seem very reliable, you turn around and say, oh no, it can only be found in very certain specific contexts by very specific people. Okay, so I'm just highlighting, again, I don't mean to pick on Carol Dweck, but I'm just highlighting that when you get failed replications, it's perfectly reasonable. There could be perfectly good reasons why a study doesn't replicate. That has nothing to do with the original study being bad. I think what's problematic is when you get replications that fail and the authors point to anything they can, the original authors point to anything they can as to explain why it doesn't constitute a fair replication, a fair attempt. Their study was perfect, and all studies afterwards aren't. And there is also this kind of post hoc element to it, where every study that works, Carol Dweck thinks uses as evidence that her theory works. And I don't mean, again, Carol Dweck, but I mean you find this regularly. Any study that does work, the original authors have tended to say, that study's brilliant, look, it found the effect. Any study that doesn't find the effect, well, they're not doing it right, they don't know how to do it. Now I cited this study down here just to remind myself, but also if you want to look it up. Protzko and Skruller have a study in Site Archive, a preprint. This actually has come out now, it's been published as well, but you can still find it as a preprint. And they looked at the skill caliber of replicators. They wanted to know if you look at how experienced the teams are by any number of ways, years since graduation or however they did it. It could be the number of papers they published. I think that's what they actually did. And you look to see, is there a relationship between how experienced the replication team is and their success at replicating? And he said there isn't. So Carol Dweck's kind of hinting at that here, that you have to be really experienced and knowledgeable in order to get these effects. But when Protzko and Skruller looked into this, but they didn't find any evidence for the claim that only really experienced, skilled labs are good at replicating. Okay, so on this note, I haven't left myself too much time, so I'll be quick. I want to say, it might sound negative to say that psychology hasn't really had a history of replication, of conductive replication, and that the famous findings that I was taught when I was growing up haven't replicated. But I am pleased to say that things are changing. So as we saw already, there's been a number of large-scale replication projects that have been conducted. And the APA has really been driving this. The APA is the the Association for Psychological Science, has really been driving the attempts to improve the replicability of research. Don't forget, for every single topic that I listed that hasn't replicated, that means that replication attempts have been made, which means that which is suggestive, at least, that we're moving in the right direction. And of course, the BPS as well. They've identified that this is an opportunity to really, now we know that there's an issue with the replicability of our research, and we kind of know the reasons why, questionable research practices and so on, that now is an opportunity to really improve our psychological science. And we are starting to see this. This is Roger Jonas Sorolla. He's my PhD supervisor, but more so than that, he is the editor of the Journal of Experimental Social Psychology. And when he got appointed as editor of the journal, which is one of the main journals in social psychology, in his editorial, he stated a whole bunch of things, including accepting now registered reports, but he also encouraged authors explicitly. Remember, before there was very few, only 3% of journals encouraged replications to submit replication studies. By no means is the Journal of Experimental Social Psychology unique in this. It's more and more becoming the norm now that journals are explicitly inviting replication studies. There's been a number of projects. The Pipeline Project, that's a number, I think it's 28 labs have got together. They each have some unpublished studies, and prior to publication, they're each going to try and replicate all of each other's studies. So they're going to have an idea as to what is the replicability of unpublished studies prior to them being published. There's a Psychological Science Accelerator. This is a group of people that have got together. I think they finally got some funding now, and they organize large-scale multi-lab. So I've been in one of them, and then there'll be people all around the country and all around the world trying to replicate the results. The many labs, they've done a number of studies now where they try to replicate a number of findings amongst themselves, of famous findings. And they've had mixed success. So as you can see, that's Brian Nosek summarizing the results there on his Twitter. And in many labs too, they found that they replicated, I can't even see, I haven't got my glass on, 14 out of 28, so 50% reproducibility. And the many labs tends to be developmental research. Okay, lastly, and this has happened quite recently, the Royal Society in the UK have recently started what they call a pottery barn rule. Okay, that basically means a pottery barn rule, I think, is if you break it, you pay for it. Well, applied to research, it means if you publish it, you own its replicability. You're responsible for that finding you're putting out into the world. And the Royal Society have, and it was, I will never try to pronounce this researcher's surname, but Sanjay first published a blog about it, proposing this idea a few years ago, and recently it's been accepted. And now this is huge, because what it essentially means is the Royal Society guarantees to publish any close replication of any previously study published in its psychology and cognitive neuroscience section. This commitment extends to replication studies themselves, with no limit on the number of acceptable repeats. That's massive, because that means I could, if they've published a study, I could do a replication, and assuming that and it doesn't even have to be registered, and assuming that it meets a certain quality, of course, it has to get through review. I have to provide all the information, and it has to be assessed in terms of, is it a good replication? They will publish it. And that's massive. Okay, so this is an example, and this is probably the first big step I think we've seen like this, but it's an example of how psychologists are really taking seriously the importance that we have to incorporate and integrate replication into, make it mainstream. Okay, so we have to make it part of the scientific process. And if you remember from the last couple of weeks about incentivization, researchers get promoted by having papers published. Okay, that's their promotion criteria. How many papers did you essentially publish? If you know that you can do a replication and the Royal Society for Open Science will publish it, then suddenly you've got an incentivization to conduct replication studies. Okay, that is the end of today's lecture. Just to remind you, I want to make sure that you can define what a replication is, and the different types of replication, and what makes a good replication. You should be able to review the history of replication in psychology, and overall, I think you made a pretty good case that traditionally there hasn't been very much incentive for engaging in replications, and that kind of changed round about the time that all these replication projects started to become more common and more popular, and it highlighted just how poor the replicability was of our science. And then I finished it at the end by discussing some of the changes that are occurring in psychology, some of the ongoing projects that are becoming more and more common, that are assessing the reproducibility or replicability of our studies. And as ever, having finished the lecture, all that's left for me to do is to wish you guys a great day.